Okay, so what we're going to do for this one is we're going to find all asymptotes and behavior models, holes, and graphs. So, my vertical asymptotes, which I probably should factor to figure out what those are. So this is really x plus 3x minus 3 to make sure I can't simplify. So with x plus 3x minus 3, it can't cancel with anything in the numerator. So I know that I'm going to have a vertical asymptote at x equals negative 3 and x equals positive 3. So at x equals negative 3, I have a vertical asymptote, and at x equals positive 3, I have a vertical asymptote. Then I'm going to look at my degrees so I can see what my end behavior model should be. So if I look at my original function, I have x cubed over x squared and x cubed over x squared, excuse me, simplifies to be x, right? So what that means is that our end behavior model is y equals x, is the line y equals x. So this is really f of x equals, or y equals. So y equals x is our end behavior model. So y equals x is kind of an asymptote. So if I graph the line y equals x, I'm going to do it like this so that maybe not like this, so that I can do this nice and straight. So the line y equals x is another asymptote, or an end behavior model. So that is how we would graph the top heavy parts. So we don't have any holes because nothing cancels or anything, so there are no holes. And from here, we have three different sections of our graph, less than negative 3, in between negative 3 and positive 3, and to the right of 3. So I'm going to test points in all of those to figure out what my graph looks like. So it's kind of a weird graph, but if I make an XY table and plug in points, I'm plugging points into my original function to see what the y values are. I'm not going to go back and forth between the calculator because I'm just going to do a few. But if I plug in 0 for x, I would get negative 1/9 for y. So I would plug in 0, 1/9, which my horizontal or my asymptote's a little bit off. Did I move that? Should be right there. Okay. And then if I plug in negative 2, I get 1.6. If I plug in positive 2, I also get 1.6. So at negative 2, it's at 1.6, and at 2, it is also at 1.6. So, negative 1.6, sorry, that's wrong. So it's kind of weird because the end behavior model, that line y equals x, it really doesn't matter for the inside of this graph. It will end up mattering on the outside. If I keep plotting points, I'll see that the inside of this graph looks something like this. So the middle part is behaving oddly. The only way to figure out what that's going to look like is to test points. And then if I continue to test points, I'll see that the other pieces of my graph are going to look something like this. So they're not parabolas. They're weird hyperbolic shape looking things. So that is where the rest of the graph comes from. Okay, let's go on to the next one. And double check this in your calculator. Feel free to graph it in your calculator. I'll do a couple of these in there as well. So for this one, I would want to factor first. So x plus 3x minus 3 on top, and x minus 2, x minus 3 in my denominator. So with this one, I know that I have a hole at x equals 3, because my x equals 3 cancels. And I know I have a vertical asymptote at x equals 2. And my degrees are equal, and so I know I have a horizontal asymptote at y equals 1, because x squared divided by x squared, the coefficient is 1 and 1, which would divide to be 1. And then if I plug in values and find my y and x intercepts, my y-intercept is 0, negative 3 halves. And my x-intercept You would get both positive and negative 3, but I know I have a hole at 3, so the only one that is true is negative 3, 0. So I'm going to go ahead and graph this. So I have a vertical asymptote at x equals 2, horizontal at y equals 1, and this one is similar to what we've been looking at. So I have, I guess I can graph my y-intercept as 0, negative 3 halves, which would be right there. Do it in green. And then my x-intercept is negative 3, 0. So I know this side, sorry, I don't know what happened. I know that this side is going to look like this. And if I continue to plug points in up here, like if I plug in the point 3, that would give me, that would give me 0. That's my hole. There is no value at 3. But if I plug in 2, I get 5 point something, or 2.01, so something up here. So it's going to be coming down like this, and there's a hole wherever it is hitting at 3, and then it would keep coming. So that hole would be a discontinuity in our graph. But that's how that graph should look. Okay, and then these last couple are a little bit different. Well, more of the same, but a little bit different. So in this one, it's already in factor form, and we can see that we automatically can cancel out the 2's, meaning we have a hole at x equals negative 2. This is the degree of the numerator is squared, and the degree of the denominator is x to the 4th, meaning that would simplify to 1 over x squared. So my end behavior model is going to be y equals 1 over x squared. And I have vertical asymptotes at x equals negative 3 and x equals 1. And let's see. So I'm going to go ahead and graph that, and then I'm going to use my calculator on this one. So I have a hole at negative 2, which I'll get to. I have an end behavior model, y was at 1 over x squared, which I also get to, but that kind of tells you that you're going to have something similar to like our regular graph of that looks like this. But technically, I guess it's negative. It'd be negative 1 over 2, so it's going to be reflected. So I know part of my graph is going to look like that. And then I have my vertical asymptotes at negative 3 and at 1. Okay, so I'm going to go ahead and graph this on my calculator so you guys can see my thinking on that. So I'm going to go into my y equals. I'm going to be extremely careful how I enter this. And I'm going to put the numerator all in parentheses. So negative x plus 1 times x plus 2. And I'm going to put my whole original equation in there. Close parenthesis, divided by another parenthesis for the entire denominator. And I have x plus 3, x plus 2, and I have x minus 1 squared. So I'm going to graph just so you can kind of see what our graph is going to look like. So there's, perfect. So we have our asymptotes at negative 3 and at positive 1. You can kind of see on the outsides it looks like a negative 1 over x squared graph. So if you go to second graph, it takes you to a table, which is a table of values, which is going to be extremely useful when you're graphing these by hand, but I guess using a calculator. So in here, you can go to second window, and you can set your table. You can say where you want it to start, like where you want it to go. So I'm just going to say start at 0, and this little chain, like triangle TBL, means how specific, how many decimals do you want. So you can have it go by ones and it'll go by whole numbers. You can make it go by 0.1, which means when I go back to my table, it's going to go by 0.1 so I can see what is happening. I'm going to go ahead on this one and change it to just be going by 1. and look at my table of values. So you can see that I have an error at -3. -3, 1, and at -2 where I know I have my hole. So if I look at the values surrounding that, that will help me figure out how to graph it. And I mean, you can look at the graph to graph it. The outsides are really not too tough to graph. So they would be, if you notice from the graph, they are all less than, below the x-axis. So it goes like that and like that. And then the inside is what's weird. So XY table for the inside, I would choose values like look at and see where it is at -2, see where it is at -1, and at 0, and maybe at like -2.5, like something so you can see what the end behavior on the inside looks like. So if you go back to your graph, -2 is our hole. So we actually don't have a value there. So I would look at my values right after 2 and -2. So that's when you could change it to be going by 0.1s and not graph. Go to my table. So let's see, we'll start at -2. Right after -2, well, before -2, at -1.9 it is 0.09. So at -2, not -2. At -1.9, it is at 0.09. So -1.9 is at 0.09, which means I know that there's going to be a hole really close to there, because that's where -2 would be. And then after -2, like -2.1 is at 0.12, so it's a positive as well. So yeah, I should know it goes like that. And I can continue to look at these values, like reset my table so that I can look at it going by ones. And I can see that that I can see kind of where my graph's going, like is it getting bigger or smaller? So as I'm going up, these values are getting closer and closer to 0. So as I go to the left, this is my end behavior. As I go to the left, my values are approaching 0. No. Well, they're increasing. I guess let's go up a little farther. So, do they get to be past 0? I think that they do. Maybe. Oh, no, those are my x values. Oh, I'm sorry. So, let's go back here. If I keep putting them in, if I would have looked at it close to -2, not past -2, that's what I was thinking. It would start out really high. It would kind of have a shape like a cubic graph a little bit and look like that. So you want to look at your table, you want to look at your graph, use your graph to help you with these. That's completely fine. Looks like I'm going to have to pause and make one more short video for the last 2 problems.